Welcome to section C of lesson 1-3. We're going to talk about collinear and coplanar points. Now, real quick, looking at these words, collinear. So when I look at the word collinear, I see some lovely Latin roots in here. I see the word co and line. Well, co means together, right? So if you are co-workers, you work together. And we all know what line means. So 3 points are considered collinear if they lie on the same line. They're together on the line. We have a similar thing when we look at the word coplanar. We have co and the beginning of the word planar. So the 4 points are considered coplanar if they lie on the same plane and are not actually collinear themselves, because any line can have multiple planes that intersect on it. So we'll talk about that here in a second when I have a better diagram to show you. But any 2 points are always collinear. You learned that in Algebra 1. There's no 2 points I can draw in the world where I'm not able to then draw a line through them. That's the definition of a line, right? It's the shortest distance between 2 points. Any 3 points are always coplanar because that's actually how we define a plane. A plane is a space that holds 3 non-collinear points. Now let's take a look at how lines can intersect. We can have parallel lines that are lines in the same plane that never intersect. This means that they have the same slope, and we would use the symbol like this to show that 2 lines are parallel. So if I write AB and I put my line symbol over it, parallel to DC means that I've got 2 lines in the same plane whose slopes are equal. Then we have lines that can intersect, intersecting lines. And they're simply lines that cross. Very easy. And they always cross at one specific point. So lines can't curve, so we can't then force that line to come back around and cross again. Perpendicular lines are a subset of intersecting lines. And this means that their slopes are opposite reciprocals. And the symbol for things that have opposite reciprocal slopes or perpendicular lines looks like an upside down T. So if I write line, or here I have segments, segment AB is perpendicular to segment DE in the diagram to your right. And then finally we have skew lines. And skew lines are lines that never intersect because they're on different planes. So they're not parallel, because to be parallel you have to be on the same plane, but they also never intersect. So looking here, if this was a 3-dimensional diagram here, then you would see that this line here never intersects this line here, but they are also not parallel lines. So, because they're on different planes. All right, now I want you to go through for your try-me's and answer these questions right here. Pause the video, restart it, we'll go over those questions in class. Now we're going to look at the different ways that lines and planes can interact. 2 lines can intersect in one of 3 ways. They can have no intersection in the case of parallel or skew lines. They could intersect in a point in the case of intersecting lines. And A line in the case, whoa, what happened to my spelling here, folks? Intersecting lines. Or they can intersect in a line when in fact you have the equation of the same line. So for example, the line 3y plus 2x equals 10 and 6y plus 4x equals 20, those would end up being the same line, so their intersection would in fact be a line. Now I want you to pause the video and draw an example of each kind of situation. No intersection, intersecting at a point, and intersecting in a line. A line in a plane can intersect in one of three ways. There can be no intersection in the case of a line that is parallel to the plane. A point in the case that a line passes through the plane. So this one's interesting, actually. It's something like that, if you can get a visual for it, where it passes through the plane at a single point. And then a line in the case that the line actually lies within the plane. I want you to pause and draw a picture of a line and a plane intersecting. Okay, now let's keep going. We've then got two planes can intersect in one of three ways. They can have no intersection in the case of, you guessed it, parallel planes. A line in the case of intersecting planes. And a plane in the case where the planes happen to occupy the same space. So think of this like a piece of paper laying on a desktop. That would be that the piece of paper is within the plane of the desk. They're both planes, they intersect in a plane. So